So your final exam is going to be 50 questions, all multiple choice. For the questions from your review that I'm going to go over, again, they're the ones that are most similar to the questions that are on your exam. We're going to start with the x squared minus y is equal to -2, and x minus y plus 4 is equal to 0. This is question number 4 on your review. So first thing we're going to do is we're going to take that bottom equation and solve for either x or y. I'm going to solve it for y, so that way we can just plug it in to that top equation. So we have x minus y plus 4 is equal to 0. I'm just going to move that y over, adding it to both sides to get y is equal to x plus 4. We're going to take that x plus 4, plug it in for y in the top equation. So it gives us x squared minus x plus 4 is equal to -2. We're going to distribute that negative into the x plus 4 to get x squared minus x minus 4 is equal to -2. We're going to add the 2 over. So that's x squared minus x minus 2 is equal to 0. From here, we're going to factor in order to solve. So this gives us x minus 2 times x plus 1 is equal to 0, giving us two x values, one that's 2, the other that's -1. So we're going to plug both of these values in separately to solve for y. Plugging in that 2 for x, we're going to have y is equal to 2 plus 4, which means y is 6. So that's the ordered pair 2, 6. For the -1 for x, we're going to have y is equal to -1 plus 4, which gives us a y of 3. So that's the ordered pair -1, 3. For the next one that you see is going to be number 5 on your review. You have the 2x plus 4y plus 4 is equal to 0, and 4y minus 4x is equal to -28. First thing I'm going to do is take that top equation and move that 4 over, so that way I have 2x plus 4y is equal to -4. That's also going to give me my bottom equation of -4x plus 4y is equal to -28. From here, I want to subtract these two since my y's are the same and I want them to be opposites. So I'm going to distribute that negative, change the sign on each of those terms, and that's going to give us 6x. Our y's cancel. The 28 minus 4 is 24. So 6x is equal to 24. We divide each side by the 6, and we get that x is 4. From here, I'm going to take that 4, plug it in for x to solve for y. So that's going to give us 2 times 4 plus 4y is equal to -4. The 2 times 4 is 8, plus 4y is equal to -4. Subtract your 8 over. You have 4y is equal to -12. Divide each side by the 4. And you have y is -3. So if your x is 4 and your y is -3, the ordered pair 4, -3 is your solution. Oops. Next, we're going to look at determining if the given ordered triple is a solution to the system. This is number 10 on your review. So you're given the order triple 0, 3, 5. So your x is the 0, the y is the 3, and the z is 5. And you're given the system -5x minus 3y plus z is equal to -4. -2x minus 2y plus 2z is equal to 4. And z is equal to x plus 5. So we're going to start by plugging in on the top equation. So it's going to give us -5 times 0 minus 3 times 3 plus 5 is equal to -4. From here, your negative 5 times 0 cancels. This leaves you with negative 9 plus 5. Negative 9 plus 5 is negative 4. Negative 4 is equal to 4 is a true statement. So we'll check the second equation. For the second equation, you have negative 2x, so negative 2 times 0, minus 2y, so that's negative 2 times 3, plus 2z, so that's 2 times 5, is equal to 4. Your negative 2 times 0 cancels out. You're left with negative 6 plus 10 is equal to 4. 10 minus 6 is 4. 4 is equal to 4 is a true statement, so we'll check that last equation. For the last equation, you have z is equal to x plus 5. So that's going to give you 5 is equal to 0 plus 5, which means 5 is equal to 5, which is also a true statement. So this order triple is a solution. This question is number 13 on your review. You have 2x plus 7y plus 3z is equal to negative 7. 2x plus 8y plus 6z is equal to negative 4. And negative x minus 3y minus 4z is equal to negative 3. I'm going to start using the first two, and I'm going to use or get rid of your x's out of there. So we're going to have 2x plus 7y plus 3z is equal to negative 7. And 2x plus 8y plus 6z is equal to negative 4. I'm going to subtract these. So I'm going to change the sign on each of those terms and then combine like terms. So your 2x minus 2x cancels out. The 7y minus 8y is negative y, and 3z minus 6z is negative 3z. And your negative 7 plus 4 is negative 3. From here, I'm going to use the top equation and the bottom equation and keep going with this. So I have 2x plus 7y plus 3z is equal to negative 7, and negative x minus 3y minus 4z is equal to negative 3. I'm going to multiply that bottom equation by 2, so that way our x's cancel. Your top equation stays 2x plus 7y plus 3z is equal to negative 7. Your bottom equation becomes negative 2x minus 6y minus 8z is equal to negative 6. Combine your like terms. Your x's cancel. You're left with y minus 5z is equal to negative 13. From here, use your two new equations. So that's the negative y minus 3z is equal to negative 3, and y minus 5z is equal to negative 13. You're going to combine your like terms. Your y's cancel. You're left with negative 8z is equal to negative 16. Divide each side by that negative 8, and you have that z is 2. From here, you're going to take that z value, plug it in to solve for y. I'm going to use the y minus 5z is equal to negative 13. So that will give us y minus 5 times 2 is equal to negative 13. That's y minus 10 is equal to negative 13. Add your 10 over. You have y is equal to negative 3. From here, you're going to plug in your y and your z and solve for x in one of the original equations. I'm going to use that top equation. So I have 2x plus 7 times y, which we said is negative 3, plus 3 times z, which we said is 2, is equal to negative 7. This gives us 2x minus 21 plus 6 is equal to negative 7. That simplifies to give us 2x minus 15 is equal to negative 7. We're adding the 15 over to get 2x is equal to 8. Divide each side by the 2, and you have that x is 4. So the order triple, that is your solution, is 4, -3, 2. Your row echelon is not on your exam, so we're not going to go that far with this one. I just want the order triple for it. Your next question that we're going to go over is going to be number 14 from your review. You have 5x plus 3y plus 2z is equal to 1. 3y minus 4z plus x is equal to -5. And -3y plus x minus 5z is equal to 21. If we rewrite these in standard form, we have 5x plus 3y plus 2z is equal to 1. X plus 3y minus 4z is equal to -5. And x minus 3y minus 6z is equal to 21. So I'm going to start by using our top equation and the bottom equation. So that's the 5x plus 3y plus 2z is equal to 1. And x minus 3y minus 6z is equal to 21. You'll see that your y's are opposites, so we're just going to combine like terms, canceling those out, giving us 6x minus 4z is equal to 22. From here, I'm going to use my middle equation since I haven't worked with that one and the bottom one. So that's going to give us x plus 3y minus 4z is equal to -5, and x minus 3y minus 6z is equal to 21. Once again, your y's are opposites, so they cancel. You're left with 2x minus 10z is equal to 16. You're going to use your two new equations now. So that's the 6x minus 4z is equal to 22, and 2x minus 10z is equal to 16. I'm going to multiply the bottom equation by -3 to cancel out those x values. So that'll leave us with 6x minus 4z is equal to 22, and -6x plus 30z is equal to 48, -48. From here, we are going to combine like terms. Your x's cancel. You're going to be left with 24z is equal to -26. Divide each side by that 24. And you have that z is -13/12. Let's backtrack from this because this should be 26, not 24. This should be 26z, not 24. So this should be 26z is equal to -26. You're going to divide each side by the 26, and you get that z is -1. That's a lot better. So from here, you're going to take that -1, plug it in for one of the z values to solve for x in your two new equations. If I use the 2x minus 10z is equal to 16, that gives us 2x minus 10 times -1 is equal to 16. That simplifies to give us 2x plus 10 is equal to 16. Subtract your 10 over. All right, so this gives you 2x is equal to 6. When we divide each side by 2, you get that x is 3. So plugging the 3 in for x and the -1 in for z, you're going to have 3 plus 3y minus 4z, which is -1, is equal to -5. That's 3 plus 3y plus 4 is equal to -5, giving you 3y plus 7 is equal to -5. Subtracting the 7 over gives you 3y is equal to -12. divide each side by the 3, and you have that y is -4. So 3, -4, -1 is the order triple. That's your solution. Your next question, you are solving using back substitution. This is number 15 from your review. So you have x minus y plus z is equal to -3, 3y minus z is equal to 6, and 4z is equal to -3. Your z gets solved first, which gives you -3/4. You're going to plug that into your middle equation to get 3y minus -3/4 is equal to 6. This is 3y, which we're going to turn this into, we don't need to turn it into anything. The 3y can stay 3y plus 3/4 is equal to 24/4. So when we subtract the 3/4 over, our like denominators are there. So that gives us 3y is equal to 21/4. You're going to divide each side by that 3 or multiply by the reciprocal. 3 goes into 21 7 times, so y is 7/4. From here, you're going to plug the 7/4 in for y and the -3/4 in for z in the top equation to solve for x. So it's going to give us x minus 7/4 plus -3/4 is equal to -3. This is x minus 10/4 is equal to -12/4. Add your 10/4 over. That gives us x is equal to -2/4, which is -1/2. So your order triple is -1/2, 7/4, -3/4. For your next one, we're going to give the augmented matrix for the, this system of equations for the augmented matrix that's given to us. This is number 16 from your review. So you have an x column, a y column, a z column, and an answer column. So that means you're going to have 9x plus 0y, which you don't need, plus 11z is equal to -3. -6x plus 2y plus 5z is equal to 2. 7x minus y plus 0z, which you don't need, is equal to 1. And 1x, or just x, plus 0y, which you don't need, minus 8z is equal to -7. For your next question, you're determining the dimensions for the matrix it's given. This is number 17 from your review. For this one, you have 1, 2, 3, 4, 5 rows by 1, 2, 3 columns. So it's a 5 by 3. Next one, we're going to look at just E and F, and this is from number 18 on your review. For 18, for E, you're doing B times A. Your B matrix is a 2 by 3, and your A matrix is also a 2 by 3. Your two middle terms, the 3 and the 2, are not the same, so you cannot do this. You would have no solution. For C times B, however, you can do that because C is a 3 by 2, and your two middle terms are the same, so you can multiply these out. So you're going to have the matrix 0, -5, 2, 3, -4, 7, multiplied by 2, 1, 2, 5, -6, 5. So we're going to start first row by first column. 0 times 2 is 0. -5 times 5 is -25. Then first row, second column. 0 times 1 is 0. Negative 5 times negative 6 is positive 30. Then you have first row, second by third column. 0 times 2 is 0. Negative 5 times 5 is negative 25. We're going to move down now to your middle row with your first column. 2 times 2 is 4. 3 times 5 is 15. Then you have middle row, middle column. 2 times 1 is 2. 3 times negative 6 is negative 18. Then you have middle row, third column. 2 times 2 is 4. 3 times 5 is 15. Then we're going last row, first column. Negative 4 times 2 is negative 8. 7 times 5 is 35. Last row, middle column. Negative 4 times 1 is negative 4. 7 times negative 6 is negative 42. Then you have last row, last column. Negative 4 times 2 is negative 8. 7 times 5 is 35. So you're going to combine all of these now. And this should give you the matrix of negative 25, 30, negative 25, 19, negative 16, 19, 27, negative 46, 27. This question is number 19 from your review. Again, you're just finding the inverse of this given matrix. So remember, you're going to label this A, B, C, and D, and you're going to do A times D minus B times C. So that's going to give us 2 times negative 3 minus 5 times negative 9. That's negative 6 plus 45. Negative 6 plus 45, or 45 minus 6, gives us 39. You're going to take the reciprocal of that to be 1 over 39, and you're going to multiply it by switching your A and D, negating your B and C. So it's going to be negative 3, negative 5, 9, 2. From here, you're going to multiply in that 1 over 39 to get negative 3 over 39, which is negative 1 over 13, negative 5 over 39, negative 9 over 39, which is going to be 3 over 13, and 2 over 39. Next question we're going to find the determinant, and this is number 20 from your review. You're given the matrix 0, negative 2, 1, 2, 8, 7, negative 4, 0, 7. You're going to start this by rewriting the first two rows, or first two columns on the outside. So it's the 0, 2, negative 4, negative 2, 8, 0. You are going to multiply from top to bottom. So that's the 0 times 8 times 7, which is 0. Then your negative 2 times 7 times negative 4, that's 8 times 7, which is 56. Oops. Then your 1 times 2 times 0, which is 0. And you're going to subtract that with your multiplication from bottom to top. So negative 4 times 8 times 1 is negative 32. 0 times 7 times 0 is 0. And 7 times 2 times negative 2 is negative 28. You're going to combine this and then subtract. So you're going to have 56 minus your negative 32 minus 28 is going to give you negative 60. You're going to add, you'll add these and you'll have 116. This question on your review is number 21. You're using Cramer's rule to solve. So we're going to start by finding D. You're going to have negative 1, 1, negative 1, 2, negative 1, 1, 3, 2, 1. Rewrite your first two columns. Find your determinant. So you have negative 1 times negative 1 times 1 is 1. 1 times 1 times 3 is 3. Negative 1 times 2 is negative 4. Minus 3 times negative 1 is 3. 2 times 1 times negative 1 is negative 2. And 1 times 2 times 1 is 2. This gives you 4 minus 4, which is 0, minus 3 minus 2 plus 2, which is just 3. So your determinant is negative 3. You're going to then switch out your X column with your answers. So you're going to have negative 15, 18, 6 as your X column, 1, negative 1, 2 for your Y column, negative 1, 1, 1 for your Z column. Rewrite the first two columns. You're going to multiply down from top to bottom. Negative 15 times negative 1 times 1 is 15. 1 times 1 times 6 is 6. And negative 1 times 18 times 2 is negative 36. You're going to subtract that from multiplying bottom to top. So it's going to give you 6 times negative 1 times negative 1 is 6. 2 times 1 times negative 15 is negative 30. And 1 times 18 is 18. This will simplify to give us negative 15 minus negative 6, which means your D sub X is negative 9. From here, we're going to find D sub Y. So our X columns stays negative 1, 2, 3. Y column changes out to be negative 15, 18, 6. Z column stays negative 1, 1, 1. Rewrite the first two columns. Multiply from top to bottom. Negative 1 times 18 times 1 is negative 18. Negative 15 times 1 times 3 is negative 45. Negative 1 times 2 times 6 is negative 12. From bottom to top, 3 times 18 times negative 1 is negative 54. 6 times 1 times negative 1 is negative 6. And 1 times 2 times negative 15 is negative 30. This then simplifies, giving us negative 75 minus negative 90, which means D sub Y is 15. Next, we're finding D sub Z. So we're keeping our X column negative 1, 2, 3, keeping our Y column 1, negative 1, 2. Z column changes out to be negative 15, 18, 6. First two columns get rewritten. From top to bottom, negative 1 times negative 1 times 6 is 6. 1 times 18 times 3 gives us 54. Negative 15 times 2 is negative 60. Minus, from bottom to top, 3 times negative 1 times negative 15 is 45. 2 times 18 times negative 1 is negative 36. 6 times 2 times 1 gives us 12. This then simplifies to give us 0 minus 21, which means D sub Z is negative 21. Your answers are going to go in the form of an order triple of d sub x over d, comma d sub y over d, and d sub z over d, which would give us negative 9 over negative 3, 15 over negative 3, and negative 21 over negative 3, which all simplify to give us the order triple 3, negative 5, 7. Continuing on with number 13 from your review, which is number 22 on your actual review. You're solving for x, and 2x plus a is equal to b, where you're given two different matrices, one for a, one for b. So we're going to first solve for x within our equation. Move your a over, subtracting it from both sides. So you get 2x is equal to b minus a. Then divide each side by the 2. So you're going to find b minus a first, and then divide every term by the 2. So starting with b minus a, you're going to have 20, negative 7, negative 6, negative 1, minus 10, 3, negative 12, and 14. So that's going to give us 1/2 times the difference of 20 minus 10, which is 10. Negative 7 minus 3 is negative 10. Negative 6 minus negative 12 turns into negative 6 plus 12, which is positive 6. And negative 1 minus 14 is 13. Or sorry, negative 15. So from here, we're just going to multiply everything by 1/2 or divide it by 2. And that gives you 5, negative 5, 3, negative 15 over 2. For your next questions, we are going to work with A, B, and C and find each of the following. For A, we have negative 1/4 times C. So we're going to do negative 1 over 4 times the matrix of negative 1, 3, 2, negative 4, 5, 8. This is number 23 on your actual review, by the way. So this gives us the matrix positive 1/4, negative 3/4, negative 2 over 4, which is negative 1/2. Negative times negative is a positive, so 4 over 4 is 1. Negative 5 over 4, and negative 8 over 4, which is negative 2. For B, we're doing 3a minus 2b. So that's going to be 3 times 4, 1, negative 2, 0, 5, 6, minus 2 times negative 1, negative 2, negative 5, negative 4, 6, 7. So we're going to multiply in the 3 and the negative 2 first, and then add everything. So it's going to be 12, 3, negative 6, 0, 15, 18, plus 2, 4, 10, 8, negative 12, negative 14. So this is going to leave us with 14, 7, 4, 8, 3, 4. Next for C, we're doing B times A. For B times A, you cannot do, so this one is no solution. And that's because your matrices are the same dimensions, not the two dimensions where your two inner numbers are the same. For D, we're doing C times B. So C, we have that negative 1, 3, 2, negative 4, 5, 8. And we're multiplying that by B, which is the negative 1, negative 2, negative 5, negative 4, 6, 7. So we're going to go first row by first column first. So -1 times -1 is 1. 3 times -4 is -12. Then first row, second column, -1 times -2 is 2. 3 times 6 is 18. First row, third column, -1 times -5 is +5. 3 times 7 is 21. Then second row, first column, 2 times -1 is -2. -4 times -4 is +16. Then second row, second column, 2 times -2 is -4. -4 times 6 is -24. Then second row, third column, 2 times -5 is -10. -4 times 7 is -28. Moving down to your third row, first column, 5 times -1 is -5. 8 times -4 is -32. Then third row, by second column, 5 times -2 is -10. 8 times 6 is 48. Lastly, bottom row, third column, 5 times -5 is -25. And 8 times 7 is 56. So we're going to combine these, and we are going to be left with -11, 20, 26, 14, -28, -38, -37, 38, and 31. For number 15, which you are stating the dimensions, this is number 26 on your review. Your dimensions here, you have 1, 2, 3 rows by 1, 2, 3 columns. So this is a 3 by 3. Next one, we are going to find the first 3 terms of the sequence. A sub n is equal to n squared over 2n minus 3. This is number 28 from your review. Your first term begins with n equaling 1. So a sub 1 is going to be 1 squared over 2 times 1 minus 3. So that gives us 1 over 2 minus 3, which is 1 over -1. Giving us a sub 1, or our first term, equaling -1. For our second term, we're going to have 2 squared over 2 times 2 minus 3. That's 4 over 4 minus 3, which means that's 4 over 1, giving us our second term, 4. And then for our third term, we're going to have 3 squared over 2 times 3 minus 3, which is 9 over 6 minus 3, giving us 9 over 3, which means our third term is 3. So your 3 terms here are -1, 4, and 3. Next, this is question number 29 from your review. You're given your 6th term is -15, your 31st term is -65. We're writing the rule for the arithmetic sequence and finding the 101 term. So to find the rule, we're first going to find D. So to find D, we're going to just use our slope formula. So it's going to be -65 minus -15 over, it's a 31 minus 6. Your double negatives turn to positives, different signs, so subtract, keep the sign of the bigger number. That gives us -50 over 25, which is -2. So D is -2. We've got to find our first term now. So we're going to use the -15 and the 6 to give us -15 is equal to a sub 1 plus n minus 1. So that's 6 minus 1 times d, which is negative 2. That gives us negative 15 is equal to a sub 1 plus 5 times negative 2. That's negative 15 is equal to a sub 1 plus negative 10, or minus 10. We're going to add our 10 over. That gives us a sub 1 equaling negative 5. So our rule for a sub n is going to be negative 5 plus n minus 1 times d, which is negative 2. So we're going to distribute in that negative 2 to get negative 5 minus 2n plus 2, which gives us negative 2n minus 3. So a sub n is equal to negative 2n minus 3. Next, we're going to find the 101th term. So we're going to plug that in for n. And that's going to give us a sub 101 is equal to negative 2 times 101 minus 3. So that gives us your negative 202 minus 3, which means our 101st term is negative 205. From here, we are going to move on to find the partial sum. This is number 30 from your review. So we have our n equaling 6. Our rule is the 4n minus 7, and our last term is the 275. So the first thing we're going to do is find n by taking our top number minus our bottom number, adding 1 to it. So that's going to give us 270. Then we're going to find our first term. So we're going to have 4 times 6 minus 7. That's 24 minus 7, which is 17. And then we're going to find our 275th term, which is going to be 4 times 275 minus 7, which is 1,093. So we're going to plug all of this into our partial sum formula. So that's going to be n over 2 times your first term plus your last term. So that gives us 270 over 2 times 17 plus 1093. That 1093 plus 17 gives us 270 over 2, which is 135, times 1,110, which means our partial sum, once we multiply, is 149,850. From here, we're looking at number 31 from your review. We're given a sequence. We're told to find the rule and the 19th term. So this, again, is number 31 from your review. From negative 11 to 4, you are adding 7. From 4 to 3, you're adding 7. From 3 to 10, you're adding 7. So D, or your common difference, is 7. Your first term is the negative 11. And your rule is going to be negative 11, not negative 10, negative 11 plus n minus 1 times 7, which gives us negative 11 plus 7n minus 7, which means our rule is 7n minus 18. From here, we're going to find the 19th term. So we're going to plug in the 19 for n. So it's 7 times 19 minus 18, which is 133 minus 18, giving us our 19th term, equaling 115. Next, we're finding the indicated sum of the sequence, which is the ninth sum in the sequence, negative 2 to the power of n times negative n plus 8 over n cubed. So we're going to plug that 9 in anywhere we see an n. So it's going to give us negative 2 to the power of 9 times negative 9 plus 8 all over 9 cubed. This is number 32, by the way, from your review. So this is going to leave us with negative 512 times negative 1 over 729. And this then gives us positive 512 over 729. Next, we're finding the partial sum. This is number 34 from your review. So the first thing we're going to do is find n. So 258 minus 9 plus 1 gives us 250. Then we're going to find our first term. So that's 2 times 9 over 5 plus 7, which is 53 over 5. And then we're going to find our 258th term. So 2 times 258 over 5 plus 7 is going to be 551 over 5. So again, you're using your partial sum, so n over 2 times your first term plus your last term. So we're going to have 250 over 2 times 53 over 5 plus 551 over 5. This gives us 125 times 604 over 5, which is then 15,100. Next, we're going to find the exact sum of the infinite geometric sequence. This is going to be number 38 from your review. No, it is not number 38, I'm sorry. It is number 35. Number 35 from your review. So first thing we're going to do is find a sub 1. Oops. So we're going to plug in that 3 for I. So we're going to have 2 times 1/4 to the power of 3 minus 1. That's 2 times 1/4 to the second power, or 2 times 1 over 8. Sorry, not 1 over 8, 1 over 16, which then gives us 1 over 8. Next, we're going to find R, which we see is that 1/4. We're going to plug it into our formula, which is a sub 1 over 1 minus R. So that's going to be 1 over 8 divided by 1 minus 1/4. This is 1 over 8 divided by 4 over 4 minus 1 over 4. So 1 over 8 divided by 3 over 4. We keep change flip. And we are left with 1 over 6. Next, we look at number 36 from your review. You're given the sequence negative 2/3, 4/3, negative 8/3, and 16/3, and it continues. We are writing the rule and finding the 15th term. To find your rule, you need to find R, or your common ratio, first. If you multiply that negative 2/3 by negative 2, you get 4/3. 4/3 times negative 2 is negative 8/3. Negative 8/3 times negative 2 is 16 over 3. So R is negative 2. Your first term, or your a sub 1, is negative 2/3. So your rule is going to be negative 2/3 times negative 2 to the power of n minus 1. To find your 15th term, we're going to plug in the 15 for n. So it's going to be negative 2 over 3 times negative 2 to the power of 15 minus 1. Your negative 15, or sorry, 15 minus 1 is 14. Negative 2 to the 14th power gives us a sub 15 is equal to negative 2 over 3 times 16,384, which then simplifies to give us our 15th term equaling negative 32,768 over 3. For 24, which is number 39 in your review, you're using Pascal's triangle to expand this. We have y plus 4 to the 5th power. So we're going to start with y to the 5th, y to the 4th, y to the 3rd, y squared, y to the 1st, and y to the power of 0. From here, we have our numbers from Pascal's triangle: 1, 5, 10, 10, 5, 1. Then that 4 gets raised to the power of 0, to the power of 1, to the 2nd power, to the 3rd power, to the 4th power, and to the 5th power. Our y to the power of 0 and our 4 to the power of 0 can cancel out. We'll be left with y to the 5th plus y to the 4th times 5 times 4 plus y to the 3rd times 10 times 16 plus y squared times 10 times 64 plus y times 5 times 256 plus that 4 to the 5th power, which is 1,024. From here, we're going to multiply to simplify and get y to the 5th plus 20 y to the 4th plus 160 y cubed plus 640 y squared plus 1,280 y plus 1,024. For our next one, we have 3x minus 2 to the 4th power, which is number 40 from your review. So we're going to start with doing the 3x to the 4th, 3x to the 3rd, 3x to the 2nd, 3x to the 1st, and 3x to the power of 0. Then we're going to use the numbers from Pascal's triangle: 1, 4, 6, 4, 1. Then that negative 2 gets raised to the power of 0, to the 1st power, to the 2nd power, to the 3rd, and to the 4th. We're going to cancel out anything that raises the power of 0 and then continue. The 3x to the 4th power is 81x to the 4th. Then you have 3x to the 3rd power, which is 27x cubed times 4 times negative 2. Then you have the 3x to the 2nd power, which is 9x squared times 6 times negative 2 squared, which is 4. Then you have the 3x times 4 times negative 2 to the 3rd power, which is negative 8. Then you just have that negative 2 to the 4th power, which is negative 16. So we're just going to simplify here to get 81x to the 4th minus 216x cubed plus 216x squared minus 96x plus 16. For our next question, we're looking at number 41 from our review. We're going to use factorials with this. So we have 19 and 16. So this is telling us to do 19 factorial over 16 factorial times 19 minus 16 factorial. Remember, factorials just mean multiplication. So this is like saying 19 times 18 times 17 times 16 all the way down to 1 all over 19 minus 16 is 3 factorial, so that's 3 times 2 times 1 times 16 factorial, which is all the way down to 1. Your 16 factorial cancels out on the top and the bottom, so you're going to do 19 times 18 times 17, which is 5,814, over 3 times 2 times 1, which is 6, and that simplifies to give us 969 for our final answer. Next one we're going to look at, we are finding the polynomial with the given zeros. This is number 42 from your review. So we are going to look at every zero that is possible. So we have that -4, we have 2 minus 5i, and 1. This also means that we also have 2 plus 5i, so you want to include that as well. You are going to multiply x plus 4 times x minus 1, and then you're going to multiply x minus 2 plus 5i times x minus 2 minus 5i together as well. Your x plus 4 times x minus 1 is going to give us x squared plus 3x minus 4. Your x minus 2 plus 5i times x minus 2 minus 5i gives us x squared minus 4x plus 29. You're going to multiply this out. Your x squared gets distributed in first, so that leaves you with x to the 4th power minus 4x cubed plus 29x squared. Then your 3x gets multiplied in to give us 3x squared minus 3x to the 3rd power minus 12x squared plus 87x. Then from here, that -4 gets distributed in to give us -4x squared plus 16x minus 116. We're going to combine our like terms. That x to the 4th drops down. For your cubed powers, you have -4x cubed and 3x cubed, which gives us a -x cubed. Then for our squared, we have 29x squared, -12x squared, and -4x squared, which gives us 13x squared. Then for our power of x, we have 87x and 16x, which gives us 103x, and that -116 drops down. Our next question, we are condensing 1/2 log 4 of x plus 8 times log 4, this should be of y, minus 5 times log 4 of z. This one is number, let me see if I can find it, number 57 from your review. So first thing we're going to do, any powers are in front, so we're going to move those to be the powers on the term that it's attached to. So it's going to give us log 4 of x to the 1/2 power plus log 4 of y to the 8th minus log 4 of z to the 5th. Your 1/2 power is the square root on x. So from here, we're going to change our addition to multiplication to give us log 4 of this square root of x times y to the 8th. So I'm going to write that as y to the 8th times the square root of x, so we can tell that that x is the only thing that's underneath that radical. Lastly, we write subtraction as division. So it's going to give us log 4 of y to the 8th times the square root of x all over z to the 5th. Next one we're going to do is going to be number 58 from your review. You have log 3 of 4x to the 5th y to the 7th over z squared. This is the same thing as saying log 3 of 4x to the 5th y to the 7th minus log 3 of z squared. We're going to separate the multiplication here to give us log 3 of 4 plus log 3 of x to the 5th plus log 3 of y to the 7th minus log 3 of z squared. Lastly, our powers move to the front of those log expressions to give us log 3 of 4 plus 5 times log 3 of x plus 7 times log 3 of y minus 2 times log 3 of z. Next, we're going to look at number 60 from your review. You have 8e to the power of negative 2x minus 9 minus 3 is equal to 7. The whole idea is to isolate the e first. So we're going to move the 3 over, adding it to both sides to give us 8e to the power of negative 2x minus 9 is equal to 10. From here, we're going to divide each side by the 8 to get e to the power of negative 2x minus 9 is equal to 5 over 4. Then we're going to take the natural log of both sides to get rid of that e. So we have the natural log of e to the power of negative 2x minus 9 is equal to the natural log of 5 over 4. ln and e cancel each other out. So you have negative 2x minus 9 is equal to the natural log of 5 over 4. Now isolate your x, add your 9 over. So you have negative 2x is equal to the natural log of 5 over 4 plus 9. Then you're going to divide each side by negative 2. Plug that all into your calculator, and you should get negative 4.612 for your answer. Next is number 65 from your review. You're converting negative 134 degrees into radians. So we're going to put that over 1 and multiply it by pi over 180. Your 180 and your 134 do simplify. They're both even numbers, so you can start by dividing them by 2 and see if they simplify further from there. When you multiply this and simplify, you should get negative 67 pi over 90. For your next one, you're converting 1,086 degrees into radians. This is number 66 from your review. Again, put it over 1, multiply it by pi over 180. This is going to give you the 180 simplifying to be 30 and the 1086 simplifying to be 181. So that's 181 times pi all over 30. Next, we're converting 34 pi over 5 into degrees. So this is 67 from your review. You're going to multiply it by 180 over pi. Your pi's are going to cancel. 5 goes into 180 36 times. So you're really doing 36 times 34, which is 1,224 degrees. Next is negative 26 pi over 3. You're converting that into degrees. This is number 68 from your review. So again, multiply it by 180 over pi. Your pi's cancel. 3 goes into 180 60 times. So you're doing 60 times negative 26, which is negative 1,560 degrees. For this next question, you're finding one positive, one negative coterminal angle. This is number 70 from your review. You have 14 pi over 3. We're going to take that 14 pi over 3 To find our positive coterminal angle, we're going to add 2 pi to it, which is the same thing as 6 pi over 3. And that gives us 20 pi over 3. So that's our positive coterminal angle. For our negative coterminal angle, we're going to take the 14 pi over 3, subtracting 2 pi from it, which is 6 pi over 3. That gives us 8 pi over 3. That's still not a negative angle, so we're going to continue to subtract 2 pi from it, which is 6 pi over 3. That gives us 2 pi over 3. Again, that's not a negative, so we're going to, again, subtract 6 pi over 3 from that to give us negative 4 pi over 3. So our negative coterminal angle is that negative 4 pi over 3. Your positive is the 20 pi over 3. For your next one, you're finding the area of the triangular park with a length of 48.9 yards, width of 75.4 yards, and the angle containing the 2 side measures of 126 degrees. You're rounding your answer to 1 decimal place. So this one, you have 2 sides and an angle, so you're going to use the formula for the area. By the way, this is number 74 from your review. So that's your side times the sine of your angle divided by 2. So we're going to have 48.9 times 75.4 times the sine of 126 all over 2, which gives us the area of 1,491.4 yards squared. Next is number 75, where we're finding the reference angle of 4 pi over 5. Remember, this has to be a positive acute angle, so I'm going to first turn it into degrees, multiplying it by 180 over pi. Your pi's cancel. 5 goes into 180 36 times. 36 times 4 gives us 144 degrees. So the only thing we have to do is subtract that from 180. And that gives us 36 degrees, which we turn back into a radian. So we multiply by pi over 180. And this gives us 1 and 5, so pi over 5. For our next one, we have a cotangent theta of 2/5, and theta lies in quadrant 3. We want exact answers, and we're finding sine of theta. This is number 76 from your review. So cotangent is what x over y. Cotangent is x over y. So that's 2 over 5. Quadrant 3, if you remember, means that you have a negative x and a negative y. So both of these are negatives. We have to find r, which is always positive. So we're going to do that by taking x squared plus y squared is equal to r squared. So that's going to be negative 2 squared plus negative 5 squared is equal to r squared. So 4 plus 25 is equal to r squared, which is 29 is equal to r squared, giving us r as the square root of 29. Sine is y over r. So that is your negative 5 over the square root of 29. That does have to be rationalized, so we're going to multiply the top and bottom by the square root of 29 to get the sine of theta equaling negative 5 square root 29 all over 29. For 39, we're finding the reference angle of negative 137 degrees. This is number 77 from your review. So we're just going to take 180 minus 137, and we get 43 degrees. Positive acute angles. Next, we're using law of sines to solve the triangle. We have number 81 from your review here. So angle C is 82.3 degrees, angle B is 58.7 degrees, side B is 27.6 feet. The first thing we're going to do is use law of sines with angle B over side B is equal to angle C over the sine of angle C over C to find side C. So this is going to leave us with the sine of 58.7 over 27.6 is equal to the sine of 82.3 over C. We cross multiply to get C times the sine of 58.7 is equal to 27.6 times the sine of 82.3. From here, we're dividing each side by the sine of 58.7. Use your calculator for this, and you get that side C is 32. From here, we're going to find angle A. And we're going to do 180 minus the sum of the two angles that we have. So that's the 82.3 and the 58.7, which gives us an angle A of 39 degrees. Lastly, we're going to use law of sines again and do sine of angle A over A is equal to sine of angle B over B. So that's going to be the sine of 58.7 over 27.6 is equal to the sine of 39 over A. Cross multiply, you get A times the sine of 58.7 is equal to 27.6 times the sine of 39. Divide each side by the sine of 58.7. And this leaves you with A equaling 20. So side A is 20, angle A is 39, and side C is 32. For your next question, this is number 82 from your review. You have angle A, side A, which is 27 inches, side C is 29 inches, and angle A is 52 degrees. This is one of those triangles where you're going to have two as a result. So first we're going to work on finding the first triangle, then we'll work on finding the second. So first thing we're going to do is find angle C, and we're going to do the sine of 52 over 27 is equal to the sine C over 29. This gives us 27 sine C is equal to 29 sine 52. Divide each side by 27. Take the inverse sine of 29 sine 52 over 27, and you should get that angle C is 58 degrees. From here, we're going to find angle B by doing 180 minus 52 plus 58, which gives us angle B equaling 70 degrees. Then we are going to find side B by doing the sine of 52 over 27 is equal to the sine of 70 over B. This gives us B times the sine of 52 is equal to 27 sine 70. Divide each side by the sine of 52. And you get that side B is 32. So this is all triangle 1. For triangle 2, you are going to take what you got for angle C, subtract it from 180 to get your new angle C. So it's 180 minus 58. So angle C is 122 degrees. Then you are going to find angle B. So 180 minus 122 plus 52, which gives us an angle B equaling 6 degrees. Lastly, you're going to find side B. So you're going to do the sine of 52 over 27 is equal to the sine of 6 over B. This gives you B times the sine of 52 is equal to 27 sine 6. Divide each side by the sine of 52. And you have that B equals 4. Next, we're going to look at number 83 from your review. You have a side A of 72 inches, side C of 81 inches, and angle A of 101 degrees. So you're going to first find angle C by doing the sine of 101 over 72 is equal to the sine of C over 81. This gives us 72 sine C is equal to 81 sine 101. Divide each side by the 72. You're going to take the inverse sine of 81 times sine 101 over 72, which you get an error from your calculator. So that means that you have no triangle here. For your next one that we're going to look at, it's going to be number 85 from your review. You're using Heron's formula to solve. First thing you're going to do is find S from this. So you're going to add up all of your side lengths, dividing them by 2. So S is going to be the 45.7 plus 31.6 plus 29.5 all over 2, which gives us an S of 53.4. From here, we're going to use the formula. So we're going to take the square root of S, which is 53.4, times S minus A, times S minus B, times S minus C. Again, you're plugging all of this into your calculator. So this gives you an area to the nearest tenth of 462.9 feet squared. For your next one, we're using the law of cosines to find the three angles. This is number 86 from your review. You have A equaling 24, B is 19, C is 27. You're rounding each of your answers to the nearest degree. So our biggest side length there is C, so we're going to use your C squared is equal to A squared plus B squared minus 2 times A times B times the cosine of C. So it's going to give us 27 squared is equal to 24 squared plus 19 squared minus 2 times 24 times 19 times the cosine of C. This is going to simplify to give us 729 is equal to 576 plus 361 minus 912 times the cosine of C. You can add, but you cannot subtract. So you're going to have 729 is equal to 937 minus 912 times the cosine of C. Subtract your 937 over. This gives you negative 208 is equal to negative 912 times the cosine of C. Divide each side by the negative 912. You're taking the inverse cosine. Of negative 208 over negative 912, which gives you an angle C equaling 77 degrees. From here, you can use the law of sines to find your next largest angle using the next largest side length. So we're going to do sine A over 24 is equal to the sine of 77 over 27. This gives us 27 sine A is equal to 24 sine 77. Divide each side by the 27. Use your inverse sine of 24 sine 77 over 27. And that gives you an angle A equaling 60 degrees. Lastly, you're just doing angle B by subtracting the two angles that you have from 180. So 60 plus 77, take that, subtract it from 180, and you should get an angle B equaling 45 degrees. Next, you are going to do number 87 from your review. You're given a triangle MNO, and you're finding the area from the given information. It tells you that if you draw this out, MNO, you have side MN, which is 13, NO is 27, and angle M is 58 degrees. So from here, we're going to just find the area by multiplying our two side lengths times the sine of our angle, dividing it by 2. So it's going to be 13 times 27 times the sine of 58 all over 2. So that gives us an area of 149 centimeters squared. Our next question is number 88 from our review. We have the secant theta times cotangent theta minus cotangent theta times cosine theta. Your secant is 1 over cosine, and your cotangent is cosine over sine. Again, your cotangent is cosine over sine, and your cosine is just cosine over 1. So our cosine thetas cancel out to be 1s to give us 1 over sine theta minus cosine squared theta over sine theta. This then simplifies to give us 1 minus cosine squared theta over sine theta, which is the same exact thing as sine squared theta over sine theta. One of those squared is going to cancel out with the bottom sign, so that just gives us sine theta as our answer. Next, we're simplifying cosine squared theta minus 1 over cosecant theta. This is number 91 from your review. This is the same thing as saying sine squared theta over 1 divided by cosecant, which is 1 over sine theta. If we keep change flip, that's sine squared theta over 1 times sine theta over 1, which then gives us sine cubed theta. Next, we're doing number 94 from your review. We have 2 times cosecant squared x minus cosecant x minus 1 is equal to 0. For this, we are going to multiply that 2 times negative 1. It gives us negative 2, so we're rewriting that negative cosecant x as 2 times cosecant squared x minus 2 times cosecant x plus 1 times cosecant x minus 1 is equal to 0. So we're going to group these together. First two terms, last two terms, factor out the greatest common factor from both. So from the first two, we're going to have 2 cosecant x. From the last two, it's just going to be a 1. So this is going to give us 2 cosecant x plus 1 times cosecant x minus 1 is equal to 0. We set them both equal to 0. So 2 cosecant x plus 1 is equal to 0, and cosecant x minus 1 is equal to 0. This is going to give us cosecant x is equal to negative 1/2, and cosecant x is equal to 1. Remember, cosecant is 1 over sine. So 1 over sine is equal to negative 1/2, and it's equal to 1. We're going to take the reciprocal of both sides to get sine x is equal to negative 2, and sine x is equal to 1. This gives us an answer of pi over 2, because this sine x cannot equal negative 2. So the only thing that we look at on our unit circle is sine being 1, so our y value is 1, which gives us the pi over 2. Next, we're looking at number 95 on our review. This is that 2 times sine squared x plus 3 cosine x minus 3 is equal to 0. We are going to rewrite this sine squared x as 1 minus cosine squared x. So it's going to be 2 times 1 minus cosine squared x plus 3 cosine x minus 3 is equal to 0. This gives us 2 minus 2 cosine squared x plus 3 cosine x minus 3 is equal to 0. Your 2 and your negative 3 combine to give us negative 2 cosine squared x plus 3 cosine x minus 1 is equal to 0. From here, we're going to factor. We're going to change the sign on each of these terms to factor out a negative 1. That then cancels out. So you have 2 cosine squared x minus 3 cosine x plus 1 is equal to 0. This is then going to factor, or you can simplify this or rewrite it. I would rewrite it to be 2x squared minus 3x plus 1 is equal to 0. You're factoring this. It's going to give you 2x minus 1 times x minus 1 is equal to 0. You have x is equal to 1/2 and x is equal to 1. So looking at your unit circle where x is equal to 1/2 and x is equal to 1, you have 0, you have pi over 3, and you have 5 pi over 3. So those three are your solutions. Your next question, which is number 96 from your review. You are using the sum and difference identities to solve sine of 285. Your 285 is 60 and 225. So this is the sine of 60 plus 225. Which means if you use your sum of sine, you have the sine of 60 times the cosine of 225 plus the cosine of 60 times the sine of 225. Look at your unit circle, take the x and y values of these. This should give you the square root of 3 over 2 times the negative square root 2 over 2 plus the 1/2 times negative square root 2 over 2, which gives us negative square root 6 over 4 and negative square root 2 over 4, which can be rewritten as negative square root 6 minus the square root of 2 all over 4. Your last question, which is number 97 from your review, you have cosine 392 times cosine 92 plus the sine of 392 times the sine of 92. You are subtracting these, so that's the cosine of 392 minus 92, which is the cosine of 300, and that gives us 1/2. Remember, cosine is your x value, so you're just looking at your unit circle and taking the x value from that cosine of 300. You will need a calculator for your final exam, and your final exam is 50 questions, all multiple choice.